Hey, Mr. Harridan here. We're going to do some molecular formula problems, okay? Now, remember, molecular formulas here, these are typically not, or let's put non-reduced formulas, okay? Empirical formulas are reduced formulas. Okay. So some examples of molecular formulas here. Remember back in the day we were doing those alkanes and cycloalkanes like C6H12. Okay. And C7H14. Those were the cycloalkanes. Well, the empirical formulas for all those is when you reduce these, you get CH2, okay? But they don't exist as CH2. The molecular formulas are C6H12, or C7H14, or C8H16, so on and so on and so on, okay? Typically, you have to worry about molecular formulas for covalent compounds here. So, compare and contrast molecular formulas to the empirical formulas in the examples written above. Okay, they all include C, H, and O. For the example we have there, the molecular formula has 6 times the C's, the H's, and the O's. Okay. What do the subscripts represent in molecular formula? They represent the actual number of atoms bonded together. Okay, how do the subscripts differ from an empirical formula? Empirical formulas are the lowest whole number ratio. Okay. How many empirical formulas does it take to make up the molecular formula? For this example, it was 6. 6. Okay. Determine the molar mass of the empirical formula. Well, our empirical formula was CHO2 here. So we have to do CH and O. 1C times 12.01. 2 times 1.01 here. And 1 times 16.00. So this is 12.01. This is 2.02. This is 16.00. Adds up to 30.03 G/moles. That is for the empirical formula. Okay. Moving on to the next example. Okay. Never mind. Oh, how does it mathematically relate to the molecule here? So, if we do the molar mass of the molecule over the molar mass of the empirical, you do 180.18 divided by 30.03, and that's how you end up with 6 times the factor of 6. Okay, moving on. Next page, page 8. Okay. Empirical formulas are written in the lowest terms. Lowest terms. Empirical formulas do not give you exact atoms of everything present, but it gives you the ratio of what they are present with. Okay. This one is reduced. So that is an empirical formula here. This one is not reduced. So that is a molecular formula here. Now here's the thing. Sometimes the molecular formula and the empirical formula are the same thing. Sometimes. Because that's usually what happens for ionic compounds. They're usually the same. Okay. Determine an empirical formula. There's a nice little witty saying here. And you're going to have to write this down every time you do one of these problems. Because I expect you to do them exactly how Mr. Aradon does it. Of course. You have to do percent to mass. Mass to moles. Divide by smallest. Multiply to a whole. Okay? Because sometimes we do not get whole numbers. Sometimes you get 0.2s and 0.8s. Then you have to multiply by 5. You get 0.25s and 0.75s. You have to multiply by 4. 0.3s and 0.33s and 0.67s. You can multiply by 3. 0.5s you have to multiply by 2. Okay, so here we go. Compound is said to have zinc, nitrogen, and oxygen. What is the empirical formula of the compound? Okay, here's how I expect you to do this. First thing we do, we write down our three elements. Zinc, nitrogen, and oxygen. Okay? Then we write down our steps. Percent to mass. Mass to moles. Should put that in a different color, but whatever. Divide by smallest. Multiply to whole. Okay. So percent to mass. The first thing I do is I take these percent signs and I assume that they're grams, especially when the percents add up to 100 like they do here. So this is going to be 34.39 grams of zinc. This is going to be 14.82 grams of nitrogen. This is 50.79 grams of oxygen. Okay. Then we divide by the molar mass of each one of these elements. So this is going to be 65.39 divide by 14.01 divide by 16.00. Do not round these numbers when I do this. So I do 34.39 divided by 65.39. I write out a bunch of numbers. What do I mean? I write out 0.525921. I write out 1.05781. Bunch of numbers. Because these middle numbers really don't matter. We do not want to be rounding here. That's the big thing. 7.5. Okay? So this is my moles of oxygen. This is my moles of nitrogen. And this is my moles of zinc. Okay? So now we're going to divide by the smallest. So when we divide by the smallest here, I'm going to divide by 0.525921. Divide by 5.25921. I'm going to divide by 5.25921. 525.921. Hey, did I tell you if you're not going to write down the steps, I'm going to just mark it wrong? Yeah, that's what I'm going to do. I decided to just now. Let's see. If they don't write down percent the mass, mass the most, divide by smallest, multiply the whole, I'm going to mark it wrong. Because that's the kind of person I am. Okay, you divide these two, you get 1 zinc. Okay, that one's easy. Then you do 1.05781 divided by 0.525921. 2.01, that's close enough to 2. So there's going to be 2 nitrogens. Okay. Then I divide 3.174375 divided by 525.921. 6.03, that is close enough to 6. Okay. When it's like, if it was like 6.2, then I don't round. Okay. But if it's the first digit is pretty good, then that's what it is. So then we know our formula here is Zn N2O6, which, if you think about it, is really zinc nitrate. Easily done. Okay, I'll do the next video. In the next video, give you a little time to process that. You guys are champions. The legend is out.